Greetings. This is just a walkthrough of the practice test. So hopefully you've already done it yourself, and yeah, hopefully you've already done it yourself. And this is just to just to confirm what you've done. Okay, so I'm going to go through this pretty quickly. So draw and identify the 2D cross section of a vertical slice not through the vertex. So opposite the base of the first following. So here's the base, and this is the vertex opposite base. So it's talking about a cross section that maybe like goes through there. So if it did that, it would kind of come up the sides and up the side there, and it would do that. And that would make a shape like that. It would be a trapezoid. That's all it's talking about. A trapezoid. Cool. Okay. If you cut through all the faces of a hexagonal prism. Hexagonal prism is like a honeycomb, right? So looks like that, and it's got and it comes like that. So if I count all the faces, I've got 1, 2, 3, 4, 5, 6 sides, right? One for each of the sides of the base, and then 2 bases. That makes 1, 2, 3, 4, 5, 6, 7, 8. That's an 8-sided shape. Okay, which is going to be an octagon. I do expect you to know those basic names of shapes that we talked about in class. Cool. How many sides would the largest two-dimensional cross-section have created by cutting through a pentagonal-based pyramid? A pentagonal-based pyramid is a pentagon, so like that, and it comes up to a point. Well, a pentagonal-shaped pyramid has 1, 2, 3, 4, 5 lateral sides. 1, 2, 3, 4, 5. And then it has the base that makes 6 sides. It is possible to get something that cuts through all 6 sides, and 6 sides makes a hexagon. So that's possible. Make a hexagon out of it. Find the area of the shaded region. Well, I would describe that shaded region by saying, yeah, that's a rectangle with a square. Oh, not square. It's not a square. It's a circle, dipstick. Not you, me. With a circle. So a rectangle minus a circle. Well, the area of the rectangle is just the base, which is 7 times the height, times 12. Minus the circle. The formula of circle is pi r squared. So pi times the radius. And the radius is just from here over. So pi times 2 squared. Okay, I'm going to type that in my calculator exactly like it looks. 7 times 12 minus pi times 2 squared. And I get 71.4336. And the units are all in yards, so it's going to be in square yards. It is important that you have your units and that they're the correct power. Areas in square yards or square something-ish. Volume is in cubics, okay? So let's look at the next problem. Find the area of this. Well, I would describe this as a rectangle plus the triangle. So the area of the rectangle is 6 times 14, right? 6 times 14. Plus, so 6 times 14 is 84. So this shape here has an area of 84 square inches. Now, the triangle here, oops, that may be a little bit trickier. I'm going to think, oh, it's not that tricky because they give us the area of a triangle is just base times height divided by 2. So 8 times 10, all divided by 2. Well, 8 times 10 is 80, divided by 2 is 40. So if I go 6 times 14 plus the 8 times the 10 divided by 2, whether you do it in pieces like down here or you do it all as one shot, you're going to get 84 plus 40, which is 124, and then the units are in inches, and since it's an area, it's in square inches. Okay. Find the area of the vertical 2D cross-section and the volume for the following shapes. I can assume that the cross-section is a plane facing you, that goes to the center of the shape. The center of the shape is like right here. So cross section would slice up through there, and it would slice right up through there. So the cross section would look like that. Cross section. First thing I'm going to do is draw that cross section. It looks like that with a half circle on top. So that tells me what I need to do. This is 9 inches from here to here. See it right there? This is 17 inches high. Okay, the area of that rectangle is just going to be 17 times, not times 9, because if it's 9 inches there, it's 9 inches there, which means it's 18 inches across. Plus, this is the area of a circle, which is pi times the radius squared. And the radius is 9 because it's right there. But that's divided by 2 since it's a half a circle. So 17 times 18, I'm just going to type that in exactly like it looks. 17 times 18 plus pi times 9 squared, all divided by 2. See, that's what I typed in. That's what I got. I mean, it equals, and I get 433.23, and this is going to be in square inches. And there I go. Cool. Oh, I got to find the volume of that. Well, the volume, it's going to be a cylinder on the bottom, right? The cylinder right here, plus half a sphere, which is spelled S-P-H-E-R-E. Okay, so a cylinder plus half a sphere. Now, the cylinder, the area is going to be the base area times the height, and this is going to be plus half a sphere, which is 4/3 times pi times r cubed. Okay, so the base area of a sphere is that circle right here. And the circle has an area of pi r squared. So pi times 9 squared, okay, times the height, which is 17, plus 1/2 times 4/3 pi times r cubed. And the radius of that sphere is the same as the radius of the cylinder. It's just times 9 cubed. I'm going to type that in exactly like that looks. Okay? I'm all about using my scientific calculator like it's designed to use. Pi times 9 squared times 17 plus 1/2 times 4/3 times pi times 9 cubed. So I typed that in, and it looks exactly like that. If you have a hard time typing that into your calculator, sit down with me for a minute and go over it. I hit equals, and it gave me a syntax error. Oh, it's because, look, I forgot to I put an extra 9 in there. I need to do times 17, like that. Or another set of parentheses like I typed in. Okay, cool. And it gives me 5,852.787, and these are in inches, so inches cubed, since it's a volume. Volume is always in cubic inches. Cool. Let's look at another one. I'm getting tired of the writing, so I'm going to change some other thing. Find the area in vertical. Oh, this is the same thing. So a vertical cross section would be a slice that goes right through that point, goes down and over. And see, I imagine this is coming up like this. And come down like that. So my cross section would come up to here, and then it would go up there. So it would look like a triangle with a rectangle on the bottom, like a little house. And this would be 6 inches from right there. This would be 4 inches from there. And it says this is 8 inches tall. Okay, so the cross section is the rectangle, which is going to be 6 times 4, plus the triangle, which is going to be the base, which is also this 6, because that's the base of that triangle, times the height, which is 8, all divided by 2. So if I type that in, 6 times 4 plus 6 times 8 divided by 2. See, I type it in just like it looks, and I get 48. So this is 48 square, or not square, cubic inches. There's my cross-section area. Now, my volume, the volume, that is going to be this rectangular prism down here in the bottom. So I'm going to call that my rectangular prism plus my cone. Rectangular prism, well, that's just 11 times 6, that's the area of the base, times the 4. Plus area of the cone. Well, a cone is a one base shape, so it's 1/3 the base area times the height. And this, I'm just going to go 11 times 6 times 4 right now, my calculator. This gives me 264 plus 1/3. The base area here is a circle. And there's my radius. Well, the radius is half of this side, which is half of 6, which is 3. So pi times 3 squared, there's pi r squared. And the height of that cone is 8. So if I type that in, and actually I'm even going to go right back, and instead of 264, I'll just go 11 times 6 times 4 plus 1/3 times pi times r, which is 3 cubed. Oh, it looked a little different. Pi times 3 cubed, not cubed, squared times 8. Okay, so I'm just verifying that I got that right. 1/3 pi times 3 squared times 8. See, there it is. And I've got the 11 times 6 times 4 over there. Excuse me, I'm yawning. That's terrible. And I get 339.398, and that is in inches cubed since it's a volume. There's the area of my cross section. There's the volume. Cool. Moving on. Use this figure. What's the area of the bounded region? Well, if I find the area of that, that's 2 by 6. 2 times 6, that's 12. And it's going to be square units. Since I don't know the units, I'll just put square units. Describe the solid by rotating the region around the y-axis. Well, if I rotate, oh, yeah, around the y-axis, that's rotating it like that, right? That's a cylinder. And I'm going to describe it actually by drawing a picture. That's a cylinder with the radius equal to 6 and the height equals 2. Well, okay, what's the volume of what's the volume of that solid? Well, the volume is going to be the area of the base times the height, and the area of the base is pi, is a circle. Pi times r, which is 6 squared, times the height is 2. I'm going to type that in my calculator exactly like it looks. Pi times 6 squared times 2, and I get 226.1946, and this is in cubic units because it doesn't have units, so it's just going to be in cubic units. Cool. Let's move on. Graph the region that is bounded by y equals 0. Well, y equals 0 is a horizontal line. Oh, it's terrible. I can't do that. I can't let that fly. That's y equals 0. Y equals 0. Y equals 0. Y equals 0 is the x-axis here. X equals 0, so there. And negative 4/5 plus 4. Well, it intersects up here 1, 2, 3, 4 right there. And the slope is negative 4, 5. So down 4, 1, 2, 3, 4, and over 1, 2, 3, 4, 5. So that is that. So we're talking about this area right here. It's a triangle, right? What's the area of that region? Well, it's going to be the base, which is 1, 2, 3, 4, 5, right? 5 times the height, which is 1, 2, 3, 4, all divided by 2, because base height divided by 2, well, that's 10. and I just won't bother units, it's square units. Describe the solid. Well, when I rotate around the y-axis, there's my y-axis. If I rotate it around there, rotate it there, that makes a cone. I'll draw the picture of that cone. It makes a cone, looks like that. The height is 4, and the radius here is 5. What would the volume of this be? Well, the volume is 1/3 the base area, and the base area is pi times the radius squared times the height, which is 4. Well, if I type that in my calculator, 1/3 times pi times 5 squared times 4, I get 104.72. After I end it, 104.72. It says compare the volume to the volume of the solid created rotating region around the x-axis. Well, if I rotate it around the x-axis, let me erase this for a second. Let me erase this. That is going to make a cone like this. That's a cone that is, here it's 4, the radius is 4, and the height is 5. So it's going to be 1/3 times pi times the radius, which is 4 squared, times the height, which is 5. If I type that in my calculator, 1/3 times pi times 4 squared times 5, that gets me 83.77. 83.775-ish, so 78. And if I'm comparing, I just say it's less. And I prove it by showing my work. Okay. Different cones, different volumes. Okay. Population of Washington. Oh, this is a density question. Population of Washington County is 189,534, and the area is this. So density, remember, equals the amount of stuff over the amount of space. So I need to take 189,534 people and divide it by 2,426 square miles. If I take that 189,534 divided by 2,426, I get 78.1, I'll round it 3, and this is people per square mile. So in other words, every square I draw that's a mile square is going to have about that many people in it. Cool. Next one. Population density of a county is 174 people per square mile. So this gives me the density. And remember, density is equal to the amount of stuff over the amount of space that it takes up. So, and the area is 1,500 square miles. So that's the space. So they gave me the density, and it equals something over 1,500. How many people? That's that. Well, I would just turn this into a proportion by putting it under a 1, and now I can take the cross product. I'll go 174 times 1,500, and I'll divide it by the 1 that's left over there, and I get 261,000, and it's going to be people. 261,000 people. Cool. 10. Fish Lake has a water surface of this many square miles. So that's an area. How many fish would you have to stock in the lake in order for the fish population density to be 550? So again, density equals the amount of stuff. So how many fish? I'm going to call that F. I don't know that. And the area is 3,907. So again, I'm just going to multiply this by 3,907 on both sides. That's going to cancel that. And I divide by the 1. So in other words, I do the same thing I did the last problem. 3,907 times the 550 gives me 214,8850. So 2,148,850 fish would have to be stocked. That's a lot of fish. 2 million fish. Wow. Okay. What is the volume of an 817.6? So what's the volume of an 8.17 gram sample of pure silicon with a density of this. So they give me the density, 2.336. And this is grams per cubic centimeter. And the density equals the stuff, the 817.16 grams over X cubic centimeters. It wants to know the volume. Well, I'm going to put this over a 1, and now I can go, I multiply these two. I always turn these into a proportion if I can. 817.6 times 1, and then I divide it by 2.336. So let me show you what I typed in my calculator. X, and it's going to be in cubic centimeters, is going to be 1 cubic centimeter times 817.6 grams divided by 2.336 grams. See, grams cancel the grams, and I just have X equals 1 times 817.6, all divided by the 2.336, which is going to give me, I typed that in my calculator, 350, and my units there in cubic centimeters. There's my volume. I set it up always on these density things. Density equals the amount of stuff over the amount of space that it takes. Okay, cool. Moving on. A cylinder has a radius 6 feet longer than 2/3 the height of the cylinder. Okay, I got to draw a picture. This is one of these where I'm drawing an equation. So the radius here, the radius is 6 feet longer, so 6 feet more than 2/3 the height. 2/3 times the height. And there's my height. Okay, so if I write this, the volume is going to be the area of the base, which is pi times the radius, and that's the radius right here. 6 plus 2/3 h squared times h. Okay, state the domain. Well, it's got to be bigger than 0, but I think here, what if it's like bigger than 0, like 1? Well, if I take 2/3 times 1, 2/3 times any positive number will give me a positive number, which will make my radius positive. So anything where h is greater than 0 will make a positive height and a positive radius. So that's my equation, and that's my domain. Cool. Moving on. A triangle has a height 5 centimeters shorter than the base. So there's the base, and there's my height, and the height is 5 centimeters shorter than the base. So it should just be minus 5. Write an equation for the area of the triangle. The area of the triangle is going to be the base times the height. Then the base is the base. Height is base minus 5, all divided by 2. There's my equation. State the domain. Well, it's going to be bigger than 0, but if I put a 0 in here, 0 minus 5 is negative 5. I can't have a height that's that. So this b minus 5, what's the smallest number I could put in there? 5. So the base has got to be bigger than 5, because anything smaller than 5 will make a negative height. Okay. A farmer with 2,000 meters of fencing wants to enclose a rectangular plot that borders on the river. So there's my river. If the farmer does not fence on the river. So my fence is going to look like this. What's the largest area that can be enclosed? Okay, so the way I have to look at this is I've got my length, and this is going to be 2,000 minus the length. That will give me what I have after I cut away the length, but I've got to divide it by 2. So that this side will be the same. So my area is going to be the length times 2,000 minus the length all over 2. Okay? Now, I need to graph that. If I graph that, you're going to have to graph it in decimals on your own. I'm graphing it on decimals right now. If I graph it on decimals, I get the length, which I'll go x times 2,000 minus x all divided by 2, I get, it's going to be a parabola. It's going to be a parabola which has a really high maximum because these are big numbers. Now, on the test, you will be able to have decimals, okay? So if I graph this, it's a parabola, and it looks like this. And it goes from 0 to 1,000, and it has an x value of 500 here. And let me check that y value again. Oh, no, I lied. I lied. Sorry. This goes to, sorry. I'm going to erase that. The boundary is not 1,000 here. It's 2,000. Oh, yeah, duh. Because it could be 2,000 wide, and it's just kind of a flat shape. 2,000. Here's 1,000, and this is 500,000. Okay? So that's telling me that if the length is 1,000, that's the area. This is the output. There's the input. My input is the length. My output's the area. So my area is 500,000, and then it's going to be square meters. Okay? You will have access to decimals for these one to ask you to maximize things. Moving on. Oh, yuck. The marketing department at Texas Instruments found that when certain calculators are sold at a price P dollars per unit, the number X calculator sold is given by this. So this is the number of calculators sold, and there's the P dollars. Write an equation for the revenue. And it tells me revenue equals number of calculators. Well, what's the number of calculators? Oh, well, that's the number X calculators, which is going to be equal to 21,000 minus 150p. And the P is the price. Revenue equals calculators times the price. Cool. What unit price should be used to maximize revenue? So I need to graph this thing. I need to graph this. If I graph this in a calculator or my decimals thing, I get 21,000. I just got to type that in. Sorry, you can't see what I'm typing in. You're going to have to type it in on decimals your own then. 21,000 minus 150p times p. 21,000 minus 150p, and I'll put x times x. And that gives me, okay, and if I'm putting that in, it gives me a quadratic, and I'm just scrolling up and up and up until I see its maximum. Wow, it's taking me a bit to get to this. Okay, and it's up at around 700 some odd thousand. I get the point 70, 735,000. So if I graph this, it looks like the quadratic there, and I get the point 70, 735,000. Okay, so what unit price should you use to max revenue? Well, that's the input, $70 right there. And what's the maximum revenue going to be? 735 million. Or 1,000, excuse me. How many calculators? Well, that's how many calculators? That's X, because that's the number of calculators. And X equals 21,000 minus 150 times 70, which is 21,000 minus 150 times 70. I'm typing that in my calculator. Gives me 10,500. calculators. That's how many should sell. Okay, so this goes a little above beyond what we're looking at, but it's still the same principles. Okay, next question, 16. A cylindrical tank in a factory contains this many 64 cubic meters of paint. Find the dimensions of the tank, radius and height, that will minimize the amount of steel required to make it. So the volume is this. Well, in a cylindrical tank, that looks like a cylinder. There's my R and there's my height. The volume is equal to base area, which is pi r squared, times the height, which is that. Okay. So if I want to minimize this function, the volume, it says, is 64 cubic meters. So pi r squared times height. Okay, so I want to minimize this function. Well, to minimize this, I need to set this equal to a variable so I have an input and the output. Well, wait a second. This is my volume. Minimize the amount of steel. The amount of steel is the surface area. Okay, so if I want to minimize this, the surface area is equal to 2 pi r squared h, or RH, plus 2 pi r squared. Let's do this. If I solved this for a variable, if I divided both sides by pi r squared, there's an equation that I get h equals 64 over pi r squared. And if I put that in for h, that gives me my surface area equals 2 pi times r times h, which is 64 over pi r squared, plus 2 pi r. Now I have an equation where the input is r and the output surface area, and I can minimize this. I just got to type this into Desmos. So if I graph that in Desmos, if I graph that in Desmos for a moment, 2 pi times r squared, and r squared was, I got to look back here for a moment, sorry guys, 2 pi r h, 2 pi r h, which is 64 pi r squared, okay. 2 pi r, and then there's pi times r squared, all divided by, whoa. Okay, sorry, I'm confusing myself. 2 pi r, 64 pi r squared. Okay, I gotta get this. Sorry, I can't remember things from 1 second to second. Okay, so 2 pi r times 64 all over pi r squared. Okay. Two pi r times 64 over pi r squared. Did I get that right? Yep. Plus 2 pi r. Okay. Plus 2 pi r. Plus 2 pi r. Plus 2 pi r. Okay. Now, if I minimize that, minimize means I need to find the smallest value it can be. If I minimize that, sorry, I'm going to write down some numbers so I don't go back and forth. So what I did is in Desmos, I graphed this. I graphed y equals 2 pi x times 64 over pi x squared plus 2 pi x. Okay, and I got something, it looks like this. There is something over here too, but I don't care about this because x can't be negative because I'm using x for my radius. And I got the point. It's right there. I got the point 4.514 and 56.719. That tells me the dimensions. My R, which is the X value, the radius would be 4.514 meters, and the height would be 56.719 meters. Those dimensions would minimize the amount of steel needed to make that. Okay? That's a complicated problem. It's great for a review. Lousy for a test. Anyway, I need to buy bark to finish landscaping. I have 4 flower beds. They measure 80 by 10. They measure 3 by 12, and obviously these are not to scale. They measure 10 by 20 and 3 by 22. The bark needs to be 6 inches deep. This is like a bark problem. Oh, it is a bark problem. So I need to find the area of all these. Well, 8 times 10 is 80. 3 times 12 is 36. 10 times 20 is 200. And 3 times 22 is 66. And if I add all these together, 80 plus 36 plus 200 plus 66, 6 plus 6 is 12, carry the 1. 8, 9, 12 plus there's 12 plus 6 is 18, carry the 1. I get that the area of all these things is 382 square feet. And at 6 inches deep, remember, I don't multiply it times 6. I'm going to multiply it times 1/2. So 386 times 1/2 gives me 193 cubic feet. Okay, so that's my volume that I need. And it says I can buy it by the bag, which is 625. So if I buy it by the bag, I'm going to need 193 divided by 2. I'm going to need 96.5 bags, which means you need 97 bags because you can't buy half a bag. And that each bag is going to be 625. Well, 97 times 6.25 is going to give me 606.25. $606.25. That's by bags. Now, if I buy it in the bulk, I need to convert this into cubic yards because it is in cubic yards, right? Well, if I divide this by 27, and the 27 I get from multiplying 3 by 3 by 3, or 27 cubic feet in a yard, 193 divided by 27 gives me 7.15 cubic yards. And if I multiply that times $60, so that times 60, that gives me $428.89, and it's cheaper to buy it in bulk. Guys, that's it. That's the test. Good luck. Practice those, and I'll see you next time. The test is much shorter than this. This gives you a much more comprehensive example. Talk to you next time. Bye-bye.